Welcome back on Electrical Engineering 2. Again, we're still on our problem solving, and now we're gonna have a look on the exercise 1.2, exercise 8, and exercise 12. We just want to grab the concept of the two. So, this is gonna be our last problem solving under exercise 1.2. But if you have any question that you may try yourself and you want a solution to it or you want an explanation to it, you can always make sure and ask it. Okay, and it's more than welcome. So here there is a concept that we want to share here, and then it's simple and straightforward as always, because everything we have explained it's just a repetition for the same thing that we have been doing. Okay, so they give us different current with their power factor, which means if they give us our power factor in the circuit, as I said, we need to draw a phase diagram. So we take this gonna be this angle, and then from this given power factor we're gonna get this, from this given power factor you're gonna get this. Okay, so now, as I said, if a power factor is given in the problem, any given angle in the problem, we need to draw our phasor diagram. So in order for us to draw our phasor diagram, as we discussed already, we say we need to have a reference, and in this case our reference is the voltage. Why the voltage? Because it has an angle to it. The current, we only have the magnitude with their power factor angle, and we say the power factor angle is the split in angle between the two, split in angle difference between the voltage and the current. So now we are required to draw the phasor diagram. What do? We come here, we start with our reference, which was the voltage, because we know its angle, and then you can see with the supply current, they say it's lagging. Lagging, what does that mean? It means the current is coming behind it. And then there's the power factor. The given power factor is the split angle between the two. The split angle between the two, the difference in angle between the two. So if you say 20 minus 33, then you're gonna have minus 13. So that you can come here. My supply current is gonna be at the angle of minus 13. Okay, we do the same for I1, but remember for I1, when you look, they didn't say if it's leading or lagging. We don't know. So we need to come into the circuit and see that this is I1, because you have a combination of a resistor and a capacitor. The power factor is going to be what? It's going to be leading. Leading, why? Because of a capacitor. So therefore you're going to come here, say I1, it's leading, split in difference is 25, and therefore if you say 20 plus 25, you have 45. So you're gonna come here, my I1 is gonna be at the angle of 45. Okay, then we look at our I2. I2, it was given, they give us the power factor, but they didn't specify if it's leading or lagging. We go again in the circuit, we see I2, it's a combination of a resistor and a coil, and then we know that with a coil the power factor is always what? Lagging. So we can come here, this car it lagging somewhere there. The speed difference in two is 50. 50 is the power factor angle, and therefore if you take 20 minus 50, then you have minus 30. That will be the angle of our I2. Once you have done this, what comes next? It's just your Ohm's law, Kirchhoff junction law, and it's done. So as you can see here, we take our I2 on minus 30, and therefore we were asked to calculate the component on each branch. So you apply your Ohm's law, because the voltage is the same. It's going to be E minus I1, then you get the Z1. This part will be your resistor, this will be your capacitance, then you can change it to capacitor. You do the same for Z2. This is your resistor, and this is your inductance, and then you can get your inductor. Okay, but remember, in the branch 3 we didn't know what is the value of the current, but the good news is what? we apply Kirchhoff junction rule. The current into the junction, which is the supplier current, is equal to the sum of the current away of it. Okay, so we can see that we know the supplier, we know our I1, we know our I2. The only unknown become I3. Therefore we calculate our I3, and then we calculate our Z3, we get our R3, we get our ZL3, and when that just a repetition of what we have been doing. Okay, and then on the second question, this we must calculate the total impedance. Ohm's law, the supplier current and the voltage, the supplier voltage. Admittance is just the inverse of the impedance. So you can see that things are really easy. Once you understand the concept, you just need to master the small concept. Okay, and now we're gonna have a look on the last question, which is question 12. And then on question 12, there's just a small trick. Once you solve that trick, you have solved already your problem. Okay, so we know with Kirchhoff, okay, if the current is going into a junction, let me do this. Let's do this. We know that with Kirchhoff, if the current is going to a junction, it positive, out of it is negative. And again, we know that if Kirchhoff, when the current is going this direction, the voltage drop is always go in opposite direction of the current. Okay, so let's check in the circuit if we want to have that repetition. The idea is that every time they give us a given voltage in the circuit, where they give us the arrow, we need to check if this arrow is going in the right direction. Can you see? And therefore we come here, this arrow from the supplier here, or a positive and negative, will tell us the current is going in this direction. So when you come with this current, it's split in three. You have this current is going I1, you have your I2, and as well your I3. So you can see that the current is going in this direction, and as well this voltage that are going both of them in the same direction. Can you see? This doesn't respect Kirchhoff law. Kirchhoff rules doesn't respect them. So we need to correct this vector. And to correct this vector, which means we need to turn it around. We come here, we turn it around so that this arrow can face in the opposite direction of the current. Okay, so how do we correct it? Just by taking the way it was given and we add an angle of 180, and that's how we are going to correct. And then once you have corrected, because the given voltage was in instantaneous, we change it to RMS. And once you have correct just this V parallel, already you have solved your problem, because everything that comes next is straightforward. Okay, so we can see that the supplier voltage is going to be equal to the voltage addition of the voltage drop. Let's look at in our circuit and see what we saw there. Okay, so you can see that we have a parallel of what? This branch, that branch, and that branch. Therefore, this voltage here that we have correct, this voltage here is going to be the voltage across this parallel. Okay, so what Kirchhoff tells us? The supplier voltage equal to the addition of the voltage drop, which means V parallel plus V series. Okay, and therefore now you come here, you apply your Kirchhoff my rule or loop rules. You apply this, you have the supplier voltage, you have the V parallel, the unknown is V series. Once you get your V series, you change your XC to your C to XC, and then you calculate your Z series. Once you get your Z series, you calculate your series current, which is the same as the supplier current, and that's it. Okay, and then once you have get the supplier current, now you have been asked to calculate the unknown coil component. But remember, the voltage parallel is going to be the same voltage, but we can calculate the current in I2 across a resistor. We go up, we calculate the total impedance of that branch on top, so that we can get our I3. And then we apply Kirchhoff junction rule, whereby our I1 will be the unknown, so that you can get the I1, the current across the inductor. Once you have get the current across the inductor, and now you can calculate the value of your of the inductor. So you apply your Ohm's law. It's gonna be the V parallel divided by I1, and then you can get your component, your resistor, and as well your inductor. And now the last question, we were asked to calculate the complex power. As I've explained it, this is gonna be the complex power. We always conjugate the current, always. So the current is going to be a negative angle. It was positive, it's going to be negative. If it was negative, it's going to be positive. You need to conjugate it, so that this will be the value of our complex power. If you change it to rectangular, this is the value of your active power, and this is your reactive power. Everything is just straightforward. I may go a bit fast, but you can see that everything is just forward, and just take your time. Download the memo because it's going to be available to you. Ask questions where you don't understand.